All right, so welcome back. Not that you went anywhere, this is an online class, but now we're going to get into how to manage objects in kind of more uniform way. We've talked about how to wrap them with bounding boxes, how to use those to detect collisions, for example, with the separating axis theorem, and eventually we're going to add more behaviors to our objects, like even physics, right? And so we'd want to have sort of a way to combine all of these different aspects of an object in our engine into kind of a fundamental unit. And that unit we're going to sort of call an entity, right? And if you can think about how is an entity different than a model? How is an entity different than a rigid body? How is it different than the physics? Well, it's kind of the container that contains everything, right? So you may have the model, which contains your geometric data, the mesh, and you may have a rigid body that describes how that mesh interacts with other objects in the scene. And the entity is the way that those objects maybe can communicate with one another to actually produce a type of behavior. So let's kind of talk a little bit about it, right? If you can think about your mesh as being sort of your object. So in this case, your mesh is like this spinner or whatever, and then the rigid body is sort of what the kind of wraps that spinner. So if you were to have it in a game engine, right, this is the bounding volume of the spinner, and you may have different kinds of bounding volumes based on what kind of objects. For example, something that hugs the curvature a little bit more accurately, and then you have to model that more correct. Another idea, for example, too, is imagine you have a bunch of different objects and you want to wrap them all up as a single object. I think given this is sort of something that you may have run into in the midterm practical, right, where you had to take multiple objects and sort of wrap them and give them all sort of respective behavior, that they all kind of behave in the same way compared to one another. So you could do that by wrapping them in an entity or something like that. So ultimately an entity is just sort of a container. It's just a wrapper around a number of other things that we may be using underneath the covers. For example, like I said, maybe a mesh or multiple meshes, the rigid body and the behavior of the object in the scene. And so if you are familiar with Unity, for example, Unity has this concept, it's called a prefab. Right, and in a prefab you can have many different objects, a variety of hierarchies, and this can include textures and a lot of other things like scripts and behaviors and so on. Same thing with an Unreal Engine, where they call the same concept an actor, and it's effectively the same concept. Although I'm not familiar with Unreal myself, this is what I understand to be the case. And then you might be kind of surprised, but we need another container for all of these on top of it. So in a way, the entities will contain all of their own internal respective information, but on top of that, you will need some kind of manager that ensures that the internal state of these objects is correct and accurate, or is updated based on other entities that are in your scene. And so the entity manager, in a way, if you think about it, it's almost like your scene manager or your environment manager, whatever, right? Like a classic example of this is two objects are in your game and they're coming at each other, and then they hit each other. And you have a physics solver that figures out what they should respectively do, and then that physics solver then answers to your manager, to your entity manager, and tells the manager what should be done. And then that manager knows to update the respective states of the objects to tell them, okay, now you are rotating this way, you are moving this way, you are rotating that way, you're moving that way, and updates the state of these objects, and does so for each respective thing. You'll also find, and we'll talk about this week, the entity manager is where you can optimize these kinds of things by way of a spatial organization. For example, if you have these two objects that are far away from one another, you're guaranteed that they're not going to touch, right? Think about the separation axis theorem. All we had to do was come up with a plane that you could prove that did not intersect with either one of these objects. So if your entity manager is actually organizing your objects in a way where you can identify, oh, well, this object is here and this object is here, there's no way they're going to touch each other, then your entity manager can actually preempt a number of checks and you can save a lot of performance. For example, the object to the bottom left in this image and the one to the top right, if you can imagine a line, like a space in between where the entity manager is checking these two hemispheres, so to speak, of this environment, these two sections, by dividing this cube in half, it can say, well, you know what, there's no chance that this object's going to touch this other one because it's completely contained in this in this object. And so, yeah, there's a lot of optimizations that can be done at this level, and we'll talk about the entity manager as well in this lecture. Cool. So that's it for the slides. So let's jump into a little bit of code and talk a bit about it. So for this lecture, I'm going to talk about the C19 entity project in the code base, and I'm also going to upload Alberto's sort of deeper explanation on kind of coding this up. But I'm going to go through the code as well. So if you want deeper, if this is not sufficient, feel free to watch his video lecture as well. Let's quickly run it and just see what we got. As you can see here, we've got a number of objects that are, you know, in using respective OBB bounding volumes. If I rotate, I can rotate the creeper and I can move it around. And you can see when it comes into contact with Steve, it collides, and we can see that the bounding volume highlights red. However, you'll notice that it doesn't collide with, it doesn't respond to the cow, only to Steve. And so let's take a look at the code, and just to kind of see here, right, that what we're doing in the update is we're only checking the collision with Steve. Let me zoom in a bit because it's probably hard to see. So we're only checking the collision with Steve. So for example, if we check the collision with the cow, oops, with the cow, oh my god, MP cow, holy cow, huh? Okay, sorry, that was lame. Now it'll only occur with the cow, right? Which is cool. I'm not gonna push on this too long, but for example, I could do this for all of the objects in our scene. So let me add Steve, let me add the zombie, and let me add, oops, the pig. So right, I'm checking the creeper against every other object. Now we may get some bad results here. No, there we go. Great. So you can see now it's colliding with everything. And we'll start to see how you would do this in a more algorithmic way when we start talking about the entity manager. Again, this is something that you'd want your manager to do because you have all of the models in your the world, and you should be able to just have this manager do this automatically for you. So let's kind of talk a little bit about this, because one of the things that you'll notice in this code that's new is this new my entity. And first, what it's doing is it's taking a file name, which is this is the obj file, so it must be creating a model inside there, and it's also taking a name, some kind of name, and this is a new thing. And so let's go check out what's going on in this function. And here is the header of this new class, and you can kind of see that it's quite simple. If you ignore this last line, there isn't too much here that should be unfamiliar. There's this flag in memory, and we'll talk about what that is, and we'll also talk about what set axis means. But we also have this unique identifier name here, and that is what we're setting when we're setting, and we'll see why we need this new thing. So these three are a little bit different than what we're used to, but the rest is pretty much straightforward. We've got a model, we've got a rigid body, right, just like we did before, and then we've got our model matrix that is likely, you know, allowing us to manipulate our object. And in fact, if we go and we look at the app controls here, and well, actually, maybe it's in the yeah. If we look at the app controls and we process mouse, yeah, right here, you can see that we're setting. No. Where are you? Sorry. We're setting the rotation of the creeper based on the arc ball. And you can see here we're setting the model matrix, which is likely setting that for the entity. Sorry, bit of a brain fart there. And then we've got a mesh manager for actually rendering our shapes, which we're likely getting from the system, as you're probably familiar with by now in this framework. And then finally, this is an interesting one. We have got a map of entities. And so this is a map of the unique IDs, and we'll see how we use this in a bit. So let's quickly take a look at this constructor and go through it a little bit. So let's kind of open up the code here a bit so it's a little bit easier to read. And okay, let's take a look. This is the big three, right? We have our copy and whatever. We're only going to look at the constructor. So the first thing we do is we create a new model, and then we load the file name. So we pass in the file name that's going to create the model. So this entity architecture is based on using a model off of disk. And then finally, we're going to get the name of the model. And if that's not equal to nothing, then we're going to generate a unique ID. And we're going to map that unique ID and put it into our map right here. So one thing that, it's a little bit potentially confusing what's going on here. But this get name from the P model, we're going to get out of the framework. We're going to make sure that the name is not, as if the model is loaded. So this function is actually kind of doing a bit of error checking. It's making sure that we have a model loaded. So just to make sure that you guys get that. And then we're going to generate a unique ID based on this unique string. And the gen unique ID is a member function, just to make sure that you see it. And it's going to create this unique ID that then we're going to set to our unique ID. This is really just a system to make sure that we have a real value to put into our map. If you want to go through this function, we can go talk about it a little bit. And so what's going to happen here is, to generate a unique ID, we have this string that we pass in. The name is set to that. And then we create an entity. We call get entity unique ID. We're going to make sure that there are no entities in our list with that ID. If there are, we're going to add effectively a number to that until it doesn't exist. So, for example, say I have 3 Steves. We can actually go through this example. Here, let's do this. Let's, instead of the cow, let's create a new Steve. Okay. And cool. Okay. Actually, let me get out of. Okay, good. So Steve. Okay. Now we're going to load the file name, and we're going to go get the model name, and it's loaded. So Now we can go and generate this unique ID, and the string is set to Steve. We're going to get the entity, and because we already created an entity with Steve, you'll notice that pEntity exists. So it's going to go into here, and it's going to create a new name based on the index, which is going to be Steve_0, and it's going to increment the index. And then we're going to check the entity, and the entity is going to be null because there is no entity with that ID, and we're going to return. And so now we were able to create a map. Right now the map is full of, we have a creeper, we have Steve in there, and we'll talk about why the map is already populated in just a minute, and then we can go through this, and now we have our rigid body that we just created, and we set this flag to in memory. Now you can see here at this point, I'm going to get rid of this because we want to keep the cow. At this point, we've already created two objects. So why was that entity already, with that map already mapped? Well, it's a static map. So all of the entities share this map. So once you add yourself, using this map, we'll be able to see all other entities in the environment, which is a very useful thing to have. So yeah, now we've created an entity. It's in there. Very cool. So we're kind of almost done. There's a little bit more left in here that we haven't talked about. So the in-memory flag simply tells us that object is now in memory. So it's almost like a valid flag. Sometimes you'll see this pattern in engines where you'll have a flag that tells you if an object is valid or not, and if it's invalid, that's either an error and you have to fix that error, or it's just on purpose and you have to sort of validate the object before you move on. And so that's kind of actually it, really. Now we apply the set model matrix to the creeper. We create these orientations for Steve, for the cow, for the pig, and the zombie. And again, if you want to take a look at set model matrix, let's actually look at the correct one. So in my entity, let's look this other. The set model matrix is a little bit more complicated. Not complicated, but it's an abstraction. So if you're not in memory, it skips it. But otherwise, it takes that model matrix and sets it to the member of the model matrix of the entity, but also sets it to the model and to the rigid body, right? Because again, think about the entity as sort of a container in which you have a lot of other things going on. And so in that way, I don't have to deal with setting my rotation for the model and for the rigid body. And in fact, if you think about an entity, like this doesn't currently have this capability, but if, for example, in the midterm, we had, you wanted to build a plane, right, out of a bunch of different components. And so you could have a list of components that you add to an entity, and the entity then manages their position based on where they are respective to the entity, and then it almost kind of creates a new model matrix and then composites that. So this is pretty useful architecture. And then that's it, right? And again, when we're calling is colliding, it's not going to the object, it's not going to the rigid body, it's going to the entity again. So let's take a look at what is colliding does on our entity. And we can see here that is colliding, again, is very simple. If we have some kind of error, like it's not in memory for some reason, it'll return true. The justification for this is that if you have a collision that doesn't exist, it's easier to debug that than a collision that doesn't happen and you don't get notified of the error. But this could be an error. You could also put in a certain there or some kind of debug message saying you're colliding two objects and one of them isn't valid. And then ultimately you're just returning the is colliding of the rigid body. So it's almost like a direct thing. The other thing, I guess, that you want to that we want to do is render it. And so we call the renderer on these respective objects on the entity. Again, the entity, when you add to render list, first thing you take this flag, and so this is actually kind of convenient. Before we had to render our rigid body and our model separately, and now we can just do it with one call with this flag. Again, we determine is it in memory. If it's not, then we exit out, right? So that's a bug. We add our model to the render list just by calling its respective function. If the flag is set, we do the same thing for our rigid body. And now this is something that's a little bit interesting. If the axis is set, so this is a flag. Now we were talking about this flag. We're like, what is this all about? This is just kind of, again, what's called a reference geometry. If we set that flag, it will add the axis of this mesh, of the mesh manager. It'll add an axis to the render list given this particular model matrix. So for example, if we set this to true for all of the objects, what we'll see is we'll hopefully see the XYZ of all the objects as well. So let's let that code up. Maybe not. I might be doing this in the wrong place. Let's do it where it should happen, which is probably in it. All right. Great. So if we set that in the initialization, so all of the objects have the flag set to true. You can see now they all have this these axes drawn. Great. So that's kind of it for the entity. Now, I brought up the subject of the entity manager in the lecture. So again, you already have a lot of the building blocks here to manage these entities, right? You can see we're kind of doing it already here. And it's almost like, wouldn't it be better if we could create an entity and add it to a manager, and then automatically that manager would check all the collisions, will render everything if we set it to be rendered, will update the model matrices according to what it needs to be done. Like, manage everything for us. So let's take a look at this other project in here. This is the entity manager project. So let me set that as a startup project and close everything, because all these files are the same names, right? And let's run it quickly and see what we have. So here you can see now we've done what we did before by explicitly hard coding everything, and the models are colliding where they need to be. I'm not sure why these two are colliding. Oh, that's just a bug. It's just probably an initialization thing. So now you can see we're colliding with everything, even the pig. Sup, bro? Okay. So let me open this up, and let's see what's different before we jump into the code. But you'll actually see a lot of similar stuff. So first of all, instead of creating an entity, we grab our entity manager, which is in this case a singleton. And if you guys are familiar, I'm sure you should be familiar with what a singleton is at this point. But ultimately, the entity manager, there should only be one. There can only be one Highlander entity manager. I mean, so to use it, instead of having to create an object and initialize, in fact, the entity manager will manage and initialize everything for us by way of this function. And if you take a quick look at what this is doing, this is what's called actually a factory method in a way, because it's almost like a factory, right? It's outputting an object for us, and it can fail, which is nice. Having initialization of an object failing, that happens all the time, right? So if we use a manager, it can tell us, well, I tried to open this file, but it didn't exist. Do you want to try again, right? And so it gives us a little bit more control. Not that we're doing that here, but so what it starts off by doing is it creates a new entity, just like we did before. And then it checks if it's initialized, right? If it's not initialized for whatever reason, and what initialize does is it just checks if is it in memory, or were we successful in getting it into memory. As we saw in the entity before, all that is it's being set to true if we're successful in loading the model from disk and doing all that stuff. And so, great. So now we've created the entity. Then the next thing we do is we create a temp array, a PE entity temp array. And what is that? And that's just a pointer to an entity, type def. So it's just kind of a convenient thing to say instead of writing this is an array, this is a pointer to a pointer, and the reason is that's sort of a pointer to a location in the array that we have. So it's like and what we do is we try to count up until that point. And if there's an older array, we delete it. I'm not actually sure what all this other stuff is about. Just making sure. I guess this is just effectively updating the entity manager to ensure that we have only one entity in here. And I'm not entirely certain. Hold on, I'm going to pause so I can collect my thoughts a bit. Okay, I'm sorry. I totally did not know to read this correctly. This is just ultimately scaling up and down an array. So this is effectively like dealing with standard vector, but it's sort of doing it manually. The reason that you want it to be done this way is that the standard data structures provided by the C++ can add a significant amount of overhead in this. So like in theory, you don't have to do it this way, and I can try that in a minute and show you. But this is just a way to deal with to deal with the array as a vector. So you can kind of see we create a new temporary array with a size of +1. So we're going to insert 1 to the end. We're going to copy over the array. Then we're going to set the final to our new item, this new temporary item. If we have a previous one, this is just, hygiene, we delete it. And then we set our new one to the temp array, this new one that we created, and then we increment the entity count. So if you recall working on the queue, the template-based queue, that's effectively what's happening here, and you can see below, remove entity is doing exactly the same thing. If you remove it, then you create a new version of the array, and so it's dynamically scaling the size of the array every time you add or remove an object. This whole code could be replaced with using standard vector or list or whatever other data structure you want. However, with that said, this is actually the most efficient way to do it, because you can think about this may be some annoying code to write and it's hard to do once in a while, but you're going to be iterating this array all the time, and the fastest way to iterate an array is a static array, right? Like it's an actual array on disk versus using something like a list, which is a dynamic thing. You have to jump between nodes, or a binary tree where you have to, again, it's a dynamic system. You could use a heap, absolutely. You could use a vector, but one of the reasons that it's written this way is because you could implement a heap here, or you can implement this is effectively a vector, right? There are different ways to approach this. But if you were to use the standard data structures as provided by C++, there are a lot of overheads that you're doing versus writing it directly into your code. And so this is actually much more common in game engine design than you might expect, where people will write out their own data structures even though those already exist. Sometimes it's more efficient to just write the piece that you want, and it's a direct access. And if we have time, I'll go through what happens when you use a different approach. So cool. Now you have these guys, the entity added, and now what we can do is we can set the model matrix of the last entity added. So this is something that's kind of fun about having a manager, is instead of having to deal with objects, you can actually just set and forget. And if we take a look at this code, we can see, well, great, I'm going to go to the manager code. No, not responding. What did I do? Pause. All right, sorry about that. I had to restart Visual Studio for some reason. Okay, so let's pull up the entity manager here, and we're talking about set model matrix. And so setting the model matrix now, as you can see, it's going to get, you have two options. If you set the model matrix for a unique ID, then you have these two functions now. You can set the model matrix based on the unique ID. So one way would be to pass the cow or the Steve or whatever unique ID that we created. Alternatively, we can also use the set model matrix with an index. And if we pass -1 to that index, you can see that we can just set the model matrix to the most recently added model, which, for example, if AU index is greater than or equal to the MU entity count, then we just sent that to the last count. And why is -1 greater than the entity count? Well, this is an unsigned int, and so it's going to overflow to the maximum value for integers, right? It's going to be FFFFF, whatever. And so it's going to be greater than from the perspective of the compiler, which is pretty cool. So yeah, really convenient, right? So you can we can access our entities based on their index or their name. Quite convenient things that we can do to make it a lot easier to deal with, and we don't have to write a lot of code. So let's see how this actually works in reality. Well, first thing we do is we do want to move our creeper based on our location and the rotation. And so we want to update the model matrix of the creeper every frame. And you can see here's that function again, set model matrix of the creeper based on the name, which is cool. So for example, if I wanted to change this instead to the pig, not the pig, to the cow, all I have to do is just change that string. And now instead of controlling the creeper, I'm now controlling the cow, which is pretty neat, right? So now we set the model matrix for Steve. This is actually not necessary, right? Because we've done it up here. Well, we didn't do it up there, so we do need to do it here. But we could do it up there as well. So we'll leave it that way. And then what we're doing here is we're going to translate the pig incrementally. And the way this is working is, well, we're getting the model matrix of the last added thing. So this is a bit of a hack in a way, because we do want to be a bit more specific. Let's say we want to be, say, the pig. And will this work? Well, let's check it out. Do we have that function in the rigid body in the entity manager? We know that we have that for the model, setting the model matrix, but do we have a get model matrix with it? We do. So we can pass in a string to get the model matrix. And so now we don't have to do the last one. We can ensure that it's happening to the correct one. Cool. So now the pig. But for example, if I wanted to do this for the zombie, all I have to do, again, is just change the name of that string. Or is that not the name? Oh, right, I need to also set it to the zombie. And now the zombie's moving, which is cool. Great. And that's all we did. And now we need to let the entity manager update. Instead of having to do all that code before where we collided each one independently and so on, we just have to call this function on the entity manager that will update itself. And let's check out that code. And it's actually quite efficient, right? We're just going through all the entities, and for every object, we check it against every other object. Nice. right? Instead of now having to manually do it. And so this can scale up to hundreds and thousands of objects if we wanted. That might not be efficient, right? This is a nested for loop. That's going to be pretty bad efficiency, but there are other things we can do. And then finally, we add the entity manager to the render list. So before we had to add everything manually to our render list, and here, again, that is quite straightforward, where instead we can either add a specific entity by index, but if we pass -1, which is going to call this code, if we actually pass an index, it'll just call that render list. Again, it's a wrapping, it's giving us access to that object. Otherwise, it's just going to go through the entire list of objects and render them one by one. Again, very convenient function, and that's it. So pretty cool, and that's kind of the idea of all this stuff. There's really not too much more to it, and the entity manager is really there to manage these entities, and the entities are there to manage the objects inside of them. And in this way, you kind of have a very convenient and clear architecture for doing interesting things in a way that are consistent across your entire engine. So yeah, next lecture we're going to talk a little bit about the spatial optimization, which ultimately, it's kind of a step above. Your entity manager can now maybe make better decisions about how to deal with this code. So right now, we're checking every object against every other object in colliding, right? And if there's a better way to, perhaps there's a better way to do that, where we can save on performance, because this call, as you know, especially for the separation axis theorem, can be quite costly. And further, right, while the separation axis theorem and the detection of collisions is costly, every time you detect a collision, you also have to do a lot of other calculations to resolve the collision, to figure out what should happen, and those things are also costly, right? So if we can avoid all that work, we can speed up our engine quite significantly, as we'll see when we start talking about spatial optimization structures. Cool. See you in a bit.